Hey, in today's lesson, we're going to talk about two different types of sequences, arithmetic and geometric. So first, we need to know what is a sequence. So a sequence is a set of numbers written in a given order or sequence. So just a set of numbers written in a particular order. That's a sequence. So let's look at this first problem. It says to complete the table below and answer the questions. So first let's complete the table. So we have n and we have that f of n. So n is going 0, 1, 2, 3. So we can probably assume then it's going to go 4 and then 5. And then what's happening with f of n? 0, 5, 10, 15. So that should be 20 and then 25. So the first thing it's asking is what type of function is this and why? Well, if we want to know what type of function it is, let's look at the pattern and see what we notice. On the inside, we see that it is each number is going up by 1. On the f of n side, looks like we're adding 5 each time. So we can say that this is going to be linear. Okay, so what type of function is this? And we can say linear. And we know it's linear because it's going to have that constant rate of change. We could also test it out and graph those ordered pairs and see what the graph looks like. And the graph would be linear. It would make a straight line. So it's a linear function. This pattern can also be called a blank sequence. So this is also called an arithmetic sequence. An arithmetic sequence because it has something called a common difference. So let's talk about that. And that common difference can actually be seen in the table right here with the plus 5s on the f of n side. So the common difference here is actually going to be 5. All right, what is the rate of change in this? Well, the rate of change is going to be 5 over 1 or 5, okay, which is the same as your common difference. Part C says to write the equation of that function. Well, since it's linear, we're going to write it in slope-intercept form. We know our rate of change or slope is 5. And actually, I wrote y, but instead of y, I should have written f of n. So f of n equals 5n plus or minus what? Well, think about that y-intercept. So in this case, it goes through the point 0, 0, so it would have a y-intercept of 0. So it'd be f of n equals 5n plus 0, or just f of n. And then part D, find f of 25. So f of 25 is going to be equal to 5 times 25. Well, 5 times 25 is 125. So when we find that f of 25, meaning the 25th term, right? The 25th number would be 125. All right, let's try another one. All right, so let's look at number 2. It says to complete the table below and answer the following questions. So let's start off by completing the table. So the ends go 0, 1, 2, 3. So it's safe to say it's going to go 4 and then 5. And then the f of n goes 4, 16, 64, 256. So that's not adding by the same amount each time. But we know that 4 times 4 is 16. 16 times 4 is 64. Okay, so we figured out our pattern. So to get the next number, I'm going to have to do 256 times 4. Okay, which would be 1,024. And now I'll do 1,024 times 4, which is 4,024. 96. So we filled it in, and then we have to tell what kind of function it is. So if we were to graph this, would it be linear? No. But remember, we've talked about another type of function, specifically exponential, and that is exactly what this one's going to be. So this one's going to be exponential when graphed. And how do we know? And if we test it out, we could see the graph would look something like that, right? When we graph it. Okay, so that's exponential. This pattern could also be called, it says an blank sequence, but it should be a, mark out that N, a geometric sequence. Because it has, this one doesn't have a common difference. It has what's called a common ratio. And when you look in that table, that common ratio can be seen right here. So you're multiplying by 4 each time, right? Now this one, we've got to write the equation of the function. So we're not going to start off with y equals. We're going to start off with f of n equals. And then when you're talking about those exponentials, it's going to start off with your initial value, which is 4, or your y-intercept, which in this case is 4, times your common ratio. What are we multiplying by as we go further down? 4, right? 4 times 4 to the n minus 1 power. And so we can test that out and see if that works. So f of 0 is supposed to be 4, right? Well, let's plug that in. So 4 times 4 to the 0 minus 1 power. Let's see if this works. So that'd be 4 times 4 to the negative 1, which would be 4 times 1/4, which would be 1. So it's not n minus 1 because f of 0 should be 4. So it shouldn't be n minus 1. It should just be plain old n. Let's test it out now. Okay, so 4 times 4 to the 0 power. Oops, I forgot to erase that one. Well, 4 to the 0 power is 1, so it'd be 4 times 1, which is just 4. Okay, so that checks out. So the function, oops, sorry about that, the equation is going to be 4 times 4 to the n power. So the first 4 is your y-intercept. The 4 that's carried to the power, that's your common ratio, okay? All right, let's find f of 8. So if we're using that, so f of 8 is going to be equal to 4 times 4 to the 8th power. Well, if I do 4 to the 8th power, let's see, I'm pulling up a calculator real quick. 4 to the 8th power is 65,536. And then if I multiply that by 4, my goodness, what a large number this is. 262,144. So that's the thing about those exponential functions. They increase pretty quickly. Okay, so let's go to the next page. So there are two types of sequences we just talked about, arithmetic and geometric. Arithmetic is a set of numbers in a specific order, each having a common difference. Oops. Get my pen tool. Each having a common difference. And it represents a linear function when graphed. A geometric sequence is a set of numbers in a specific order, each having this one would be a common ratio. and it would represent an exponential function. Okay, so now I'm going to have you do this next section right here, 1, 2, 3, and 4. It says, given the sequences below, first, tell me, are they geometric, arithmetic, or neither? Then, identify the common difference, which we denote with a D, or the common ratio, denoted with an R, to justify part A. So if you say it is geometric, then you're going to give me a common ratio. If you say it is arithmetic, you give me a common difference. If it's neither arithmetic or geometric, then you just don't say. And then once you've done that, part C, identify the type of function for each sequence. Is it a linear function or an exponential function? So pause the video and do those 4 problems now. Okay, so hopefully you did well with these 4 problems. Pause the video, make any necessary corrections to your work. And we're going to move to the next section. So the next part talks about sequential notation. And sequential notation uses subscript notation. So let's write that down. Subscript notation, that A sub n, to identify each term in the sequence. And it's similar to function notation, which we saw on the previous page, which is that f of n. So how do we say this? You've got function notation and subscript notation. So when you're talking about this one, we read this as f of n. In the subscript notation, we read this as a sub n. A sub n. So how do we use it? So, for example, if we're given f of n is equal to 2n plus 1, find f of 4. So we already have practiced this in a previous unit on functions. But when we're finding f of 4, that's going to be 2 times 4 plus 1. So that would be 9. If we were using subscript notation and wanted to find a sub 4, so a sub 4 is going to be 2 times 4 plus 1. It's just a slight difference. Still 9. Okay, slight difference. And then as an ordered pair, so if you're in function notation, your ordered pair is written as n comma f of n. That's the same as like your x and y. And in subscript notation, your ordered pair is written n comma a sub n. And that's pretty much it. Okay, let's go to the next page. Whoops, there we go. So now it says, given the following sequences. So it looks like we've got just 2. You're going to, part A, identify the terms in the sequence using subscript notation, a sub n. So which one is a sub 1, which one is a sub 2, a sub 3, and so on. And then part B, state the next 3 terms. So tell me the next 3 terms. And then what kind of sequence is it? Is it arithmetic or is it geometric? So pause the video and complete these 2 problems. Actually, let me circle them real quick. So pause the video and complete. Hey guys, welcome back. So I finished this one, but I also added in a couple extra information that they didn't tell me, or they didn't tell us we had to add. For example, I know that this one was arithmetic, but I also went ahead and wrote down the common difference and the type of function. And I did the same thing for number 2. So definitely pause this video and make sure you make the necessary corrections to your paper. Okay. And then the only other thing is I just want you to look at this box right here. It has some really important information for you about how to write a function for sequences in order to find a particular term in the sequence. So this is something that you're probably going to want to refer back to throughout this unit. Okay, so I would definitely take the time to read through that information. And then once you've gone through and made any necessary corrections, go ahead and submit this assignment and you're ready to complete your independent practice. Good luck.